Hey guys, welcome back to another quick video for EES, the preliminary course. Today we're going to be looking at Module 4, which is Human Impacts. So as always, please ensure that you consult with your Earth Environmental Science teacher regarding anything that's covered in this video. If for whatever reason you want to get some of this information down, then feel free to pause the video and just copy at your leisure. So, to start with, when we look at human impacts, we have to identify what humans need. Now, if you've looked at any major map of Australia, you know for a fact that many of the towns that were originally founded hundreds of years ago were based around waterways and water sources. Typically, water sources such as rivers and lakes served as major inlets and habitation sites for early settlers. Now, indigenous culture, many indigenous countries around Australia, were responsible for migrating constantly from one location to another, and they often used the same thing. They would find an area where there was available fresh water and then move from there to another location. When maps were being made, they utilized waterways and water sources as major landmarks to indicate where you needed to go and where was an okay place to stay. But the question becomes, how much water is there? So if we're looking at this picture on the very right hand side, which will be very helpful for you, 96.5% of all water on this planet is found in the ocean. Now, this type of water is saline based. It's very high salt content and it's not suitable for drinking. Approximately 0.9% is considered any other form of saline water. So it might be in marshlands that are adjacent to the ocean or in salt lakes that periodically fill up with water. They too are not habitable for drinking. 2.5% of it is drinkable water, what we call potable water. Now in that 2.5%, nearly 70% of it is frozen in glaciers and ice caps. So not particularly advantageous to us who live here in Australia, but to anywhere else, particularly near the northern and southern poles, there would be tons of ice there that, if thawed, could be viable to drink. 30% of it is groundwater. Now, the groundwater that we take into account is held in what we call an aquifer. So here we have an illustrated diagram. So here we have the surface level of the soil along with plants and building structures and waterways. Beneath that we have an unsaturated zone, which is the water is not being held there for long periods of time. Instead, it would either be soaked up by plants or descend even further to a different layer of soil entirely and held there for long term. We call it an aquifer. In the old days, particularly in arid areas such as the Middle East or Australia or Africa, wells were built in order to tap into an aquifer and allow water to flow freely. Now, if the aquifer was unpolluted, that would be a great boon to anyone who had a farm for cattle or crops, where they could regularly get water out of it even though there's no lakes or rivers around. It was once believed that areas that were once very arid in Africa were actually quite temperate and they had actual rivers flowing along them. But over time, as desertification crept in, those aquifers became more and more important as the water sunk down underneath the ground level or disappeared completely. Now, beneath the aquifer, we have a very silty layer, and beneath that is sand and gravel aquifers. Now, water retention is based upon its ability to move between particles. If very small particles bound together create one large bed or one large layer, for instance like silt or in particular clay, the water will not be able to move through it very easily. If it's sandy, the water immediately flows through it because it's very porous. So if we have this fractured rock aquifer underneath that, it only holds minute amounts because it has cracks and holes and tiny tunnels almost where the water can flow in and stay there long term. And this happens through infiltration. However, if we have an aquifer here and it has to bypass the silty layer, that takes a long period of time. So this aquifer might hold short range or short duration amounts of water. Beneath that is much long-term storage, something that might have been there for 15 or 20 years or even longer. Now, groundwater isn't always available to us because it involves a lot of digging, so instead we have the surface and other fresh water, which is the 1.2% of all fresh water on the planet. And from here, we can break that down into water that's in our atmosphere, like in clouds, in living things like us, plants, animals, fungi, all that jazz, flowing in rivers, swamps and marshes, and top layer soil moisture. Now, beneath that, we also have lakes and ground ice and permafrost, which is permanently frozen material. Now, being the most valuable resource we have, water is often subject to being filtered and cleaned before it's used by people. The term I used earlier, potable, refers to water that can be either drunk, bathed in, or used domestically. So if for whatever reason you go to a camping store and they have material there that can help filter water, they often display that it is great for creating potable sources of water. So here we have a bunch of different types of water that are not particularly potable. They're not suitable for drinking or using domestically. One of them is sewerage. So that's wastewater from any domestic building. We often have what we call primary sewage water, which is removing solid waste. Secondary, which is removing carbon and nutrients. And tertiary, which kills any remaining pathogens. Now, the filtration of primary, secondary, and tertiary is why we have large sewage treatment plants. In those plants, you will see various bays where the water is pushed in, waste material is removed through chemical treatment or physical filters, and then move on to the next one. Now, I live out in Griffith, which is in the Murrumbidgee irrigation area. It's in western New South Wales. One of the towns nearby, Leeton, has a large sewage treatment plant, and it backs onto a state swamp. Now, the reason why I'm bringing this up is because one of the additional filters they have there is using native plants. If you go to Charles Sturt University in Albury, they have a similar concept set up where various plants that are suitable for extracting the nutrients or waste products are used to help filter water even finer. So in essence, we're using natural resources to filter our waste products and send it back into nature, which is a great idea and something that hopefully a lot more places endorse. Now, sadly, sewage treatment plants, primary, secondary, and tertiary filtration don't always remove everything. For instance, pharmaceuticals can be damaging towards ecosystems. They can slip through each of the filtering systems. Now, while we can't always filter everything out of it, it can serve other purposes. For instance, used in watering gardens, firefighting, industrial processes. This water that has been filtered so heavily, but still isn't suitable for drinking, we call it grey water. Now, our school here at MRHS utilizes grey water as part of our watering system. Okay, we water our ovals with it, we water the ag plot with it. So if you're watching this video and you've been drinking water from the ag plot, probably not the best idea. After that, we have stormwater. Now, stormwater is any wastewater directed off of sealed surfaces into waterways. Take, for instance, water that has come off of a roof during a major storm season and it's carrying twigs and dust and everything else through the guttering and out onto the ground. That wouldn't necessarily be a great water source to drink. I mean, plain storm water that falls directly from the sky without hitting anything and getting cupped in your hands, possibly. But once it starts collecting detritus off of a sealed surface, it starts to get much more unsafe and it's not necessarily potable. Industrial wastewater can carry various pollutants. One here is thermal. If you have, say, a dam, like up in the Blue Mountains, the first 20 meters of it are what temperature you'd expect of a lake. Go deeper than that, and it becomes very, very cold and very, very deoxygenated. The reason why is because of the broken down trees and whatnot when they first made the dam that is still decomposing. Now, it's this makes the water cold. Not necessarily the broken trees, but the fact that it doesn't mix well. Imagine we have our dam here. Top of my hand is where most of the water is being released. It goes down, out, and into the river. It's the same temperature as the river. So fish are okay with it. But if I released it down where my elbow is at the bottom of the dam, all that cold water will kill off or send into shock any fish that are downstream of it. And we refer to that as cold water pollution, which is a really big problem. We can have solid wastewater, so it's organic or suspended matter, organic compounds, chlorine. So in essence, wastewater that has been used in a manufacturing or industrial process and is carrying waste with it. Now, as a result, they are often treated on site using similar processes as sewage treatment. In paper mills, wastewater may be treated to remove organic matter to serve as biogas for waste to energy systems or as fertilizer. Now, if you live near a paper mill, you might have seen this process. Any water that they use to mash down any of the wood pulp into very thin pieces of paper has been removed, and now they're trying to extract any excess gases or whatnot from it to turn into electricity. Brilliant idea. Hopefully more places do it. Mining wastewater, and this one's pretty serious, is often high volume due to dust control, ore processing, or irrigation for rehabilitation. Taking water from numerous sources, treatment involves primary treatment such as precipitation or settling for heavy metals, silica, and phosphates. If you've ever seen the massive mining or strip mining such as Olympic Dam, you know that even though they have the massive trucks going up with the ore, they often have trucks going down that are spraying water onto the road. The reason why is to prevent any of that dust being carried out, and causing problems for nearby farms, especially if that dust has trace amounts of ore or any garbage left inside of it. Filtration, clarification, pH adjustment, and reverse osmosis follow to obtain clean water. Water is reused on site or released into the environment if the profiles of before and after water match. Now, the water that they use in order to filter the ore into its desired metals and the leftover rock and garbage and other materials can be reused. However, there will be a point where it can't possibly be reused again. So then they start to go, okay, how can we filter this out so it matches the water we took from the nearby river or from the nearby dam? Now, if it does match in terms of its biochemical and physical profile, then they can release it back in. If for whatever reason it doesn't, then they're going to have to keep a hold of it until they can filter it. Many companies who do not go into this process can actually cause major environmental disasters because they did not properly filter the water after they'd used it. Acid and mineral damage is often treated with limestone neutralization via anoxic limestone drainage, ALD, where limestone neutralizes acidic content and is sealed off from surrounding groundwater via clay plastic lining. So, imagine you've got a giant pool. That pool has been filled with water that has been subject to acid minerals. Now, over time, this has lowered its pH and it's become too hazardous to release into the environment. What they do instead is they ensure that it can't leak out of the bottom or the sides using clay and plastic, and they deposit limestone in there. The limestone will try and help neutralize the pH of the water and prevent it from escaping into the groundwater and causing major problems for nearby plants and environments. Alright, so here we have a few diagrams that you might want to get down to your book. Here we have the primary treatment of solid waste, where it's been screened, it's been processed, any grit that's been left over has been pushed down to the bottom, water's been pumped over here, and it's been separated into primary sludge or primary effluent. Now, the sludge would be more solid matter. For instance, that burrito you ate 2 days ago. The primary effluent might be the water that can still be salvaged, or that can of Coke that you drank yesterday. Now, it goes in here to the point where it reaches an aeration tank. The bubbling activity causes some of the material to bind together. Now, in that case, it becomes activated sludge, and once again, either goes down here into sludge treatment and disposal, or if it's too small, gets sucked up through this fan and goes through the cycle again. And once it's finished there, it can go out to the secondary effluent and is disinfected. Now, from this point onwards, it can go into either a natural filtration system, like the swamp area that I described for Five Bow Swamp over in Leighton and CSU in Albury, or they can use other processes. Now over here we have industrial process regarding to water. So please ensure you read through that, have a crack at it. Okay, so here we are discussing the acid mineral filtration, whether utilizing ALD. And here is a natural form of filtration. Now, these images can all be found online as well. Make sure that you have sketched something down, or you've jotted down the dot points and you've gotten cutouts from your teacher. Describe ways in which human activity can influence the availability and quality of water both directly or indirectly. Now, for the most part, when we consider our impact on nature, many of us think of the direct impact. So I've cut down a tree. That means that little koala has nowhere to live. Okay? But more often than not, the indirect impacts that we have are much more complex and further reaching. I've cut down this tree. That means the soil has less retention, which means that the nutrients of this area are going to start depleting, killing other plants around it and affecting the overall food web. So here we have three different impacts. Groundwater, which is an important resource connected to surface water. However, if we overdrain it or if we start dumping materials into it, it can have major impacts further downstream. Groundwater can flow a lot like a river. Now, if we started to mine a certain area and we're careless about how the tailings and the garbage of that particular region are being secured, it can get into the groundwater and spread much further than the original thought area of the mine. Excess nutrients via fertilizers, sewerage, animal waste, pesticides, all that jazz, they can cause major problems in waterways such as algal blooms. Now, an algal bloom is one particular organism that is gorging itself on all of these extra nutrients and creating a layer of itself across the top of the water. Now, this means that any aquatic plants underneath it aren't getting available sunlight, so they die off. When they die, they break down and produce more nutrients that feed the algal bloom even more. So algal blooms are a very big problem and indicating some major concern that we have about the environment, whether it be farmers dumping fertilizers or pesticides into the river, or it could be that we have an out of control bloom somewhere else and it's beginning to migrate. Plastic is a major concern. Now, if you've heard of, the YouTube influencer Mr. Beast, then you know for a fact that he's championing some activist organizations such as Team Seas and Team Trees. They're also responsible for helping with dealing with the major trash island that's floating around the Pacific. This island is as big as an actual island, but it's not consisting of just junk. It's primarily consisting of microplastics. Now, these microplastics are less than 5 millimeters long, and they come from various products that we just throw away. So it's just synthetic clothing, degraded plastic waste, and they can affect a host of biochemical processes inside regular organisms. For instance, it might start choking a sea turtle, or it might cause indigestion in whales and cause them to die. And it can accumulate a whole bunch of other toxins as well, such as mercury or DDT, both of which are incredibly dangerous to many organisms. Now, this picture here shows the top 10 polluters in terms of plastic being dumped into the ocean. Now, each of these rivers are a contributor. So here are every other river that goes into the ocean. And largely it's the Indus River, Yellow River, High River, Nile, Meghana, Brahmaputra, I'm sorry if I'm butchering these names, the Ganges, Pearl, Amur, Niger, and Mekong. Now, comparing to the size of this circle, which is approximately 100,000 metric tons, each of these rivers are major contributors, not because they're malicious, but because each one is a host to major cities that are on the banks of it, and they lack the infrastructure to properly dispose of waste products. If you've ever been over to India or China or many other Southeast Asian countries, you know that land is scarce compared to Australia. So as such, the infrastructure of the city is very different. Regular trash collection that we take for granted over here in Australia is very different over there. So as a result, many of the locals had to find different ways of disposing of rubbish. It might be they have a regular burn off, it might be they try to locate it, put it in one place so it'd be collected, or if they live near a river, it might go down into the river, at which point they think it's someone else's problem. So while these areas are not this is not an indictment of people who live in those regions. This is simply highlighting an issue regarding proper infrastructure and waste disposal. For instance, it was only with King George I, I think in England, did London actually for the first time get trash collection. Before then, people did the exact same thing. They just tossed stuff out their window. They didn't have proper plumbing, they didn't have trash collection, and as a result, stuff like the Black Plague was very common. And the big one here, the Yangtze River, that's probably easily 5, 6, even 7 times larger than the rest of them, or even here. So nearly 700,000 tons of waste plastic into the ocean. Over here we have eutrophication process, which is responsible for creating algal blooms. Salinisation is a massive concern, particularly here in Australia. Now, salinity is the amount of salt content that's available in groundwater and soil. If for whatever reason lots of soil has been driven up from the water table and evaporate off the top, the resulting salt crystals will grow on the surface or in the soil itself, meaning that any plant that tries to grow in there will be fighting a losing battle. Many European settlers expected the same sort of soil conditions as they had over in Europe. However, they didn't. And because they tried to change the soil conditions over here to match the plants that they brought with them, that became a major problem because it started to kill off other plants, even their own at times. So the source of the salt can include conates, which is a fossil salt deposit in the bottom of the ancient oceans, and aeolian material, which is wind-blown salt carried inland from the ocean. Both these deposits, the weathering of rocks, and salt via rainfall all contribute Australia to having a higher salt content than many other areas. Now, while primary salinity is a naturally occurring event, and we expect it, secondary salinity is caused by humans. By increasing land clearing, we're decreasing the local wildlife and plant life in particular, the ability to maintain regular water tables. By ripping out all the trees, the water table will naturally start to drip up when we plant our crops. Now, since it's close to the surface, it's more likely to evaporate, and when it does that, it leaves behind the salt crystals, leading to, you guessed it, salinization. Such high salinity degrades the quality of the land, particularly for agricultural purposes, and causes damage to built structures. Some buildings that utilize concrete can have salt formation inside of it, which decreases the integrity of the concrete over time. Now, it's not an immediate problem, but if left untreated, it can permanently damage buildings. Alright. Investigate the rehabilitation of salinity affected areas by preparing a case study. Now, this is one you probably do in class. So it's up to you to do a bit of research. Focus on your local area, in particular agriculture areas might be a good point. Many people who lived in agricultural areas might have started planting saltbush. Now, if you've never seen it before, saltbush is a plant that probably goes about the same height as a person, and it's specifically designed to take in salt with the surrounding area and excrete it out of its leaves. If you were to take one of the leaves and eat it, it would feel like someone's salted it like you would a pretzel. Same thing. So the depth and salinity of water table are monitored to check rehabilitation progress. What they should see is that the water table drops back down to its regular state and salinity decreases over time. Establishing vegetation in recharge salt-affected areas is crucial. For instance, saltbush. It's useful to use drainage and evaporation basins as engineering solutions to salinity. So this is more of a digging a large hole as an evaporation basin, focusing all of the salt-laden water to go there rather than affecting surface level areas around it. Efficient irrigation systems to reduce water table recharge. Obviously, if you're not taking out of the water table, then the water table won't rise, it won't leave salt. Urban salinity is treated by appropriate planting and maintaining watertight infrastructure. Just making sure that it doesn't ruin your local houses. Alright, soil erosion management Prac. Conduct a practical investigation into soil erosion prevention and analyze the efficacy of the method used. So, the erosion management technique is separated into two distinct areas. One is preventative, the other is control. Preventative is better in the long term, while control is trying to rehabilitate an area. Australia's soils erode faster than they are formed as water and wind remove topsoil not protected by native flora to anchor it. If we start ripping out huge amounts of wild plants, then naturally there's nothing to hold the soil down. Several years, or probably about a decade ago, Sydney was hit by massive dust storms from the west and then immediately started crying out, why have we let it get so far? The farmers are to blame. I lived out in this area for the better part of 30 years, and I can tell you for a fact that dust storms were a big part out here as well. The reason why is because we started to rip out tons of native plants, and we started to seed them with stuff like wheat, rice, vineyards. Now, this is not to say that we're entirely to blame, because we've started taking rehabilitation processes, but it's something that we could have avoided. And people in the city didn't really know anything about this, or didn't really care until it happened to them. So the moral is, just because something's happening upstream of you and hasn't hit you yet, doesn't mean it's not your problem. Everything is everyone's problems. It's just that we have different proximities to them. So, pesticides, fertilizers, and sediments are released from eroded soils into waterways, causing numerous issues. If you've got a large farm and you're spraying it with tons of pesticides and fertilizers, over time, some of that pesticide or fertilizer won't be used by the plant and will just sit idly in the soil. Now, if it rains heavily or there's tons of water going into there, it'll reactivate. So if these are released into the soils through waterways, or they're moved away due to the groundwater, then they can cause problems for an area that wasn't designed for. Replanting of vegetation and ground cover, minimal tillage, contour ploughing, strip cropping, and controlled traffic farming can minimize soil erosion, while stock management and feral animal control can assist in maintaining vegetation. Alright, so some of these terms are quite agricultural and I'll do my best to interpret them. Minimal tillage means that you're turning over the soil for a minimum amount. Most of the time when we're getting ready to do planting, you have to till the soil and turn it over at least a certain depth in order for the seeds to take root properly. Now, if you overdo it, then naturally other stuff can start growing in there, or you can lose soil. Contour ploughing might be you're contouring your crops in relation to the native topography. So if you're planting on a hill, you work with the hill by going backwards and forwards instead of just tilling it exactly how it says in the manual. Okay? More often than not, common sense is quite rare. So, by using what you know and combining it with what you have to use common sense as the glue to hold those two things together. Strip cropping is removing everything. So, in essence, some crops you would harvest what you need, but you'd leave the rest of the biological matter laying on the ground so it decomposes and gives back nutrients to the soil. Strip cropping is taking everything and leaving nothing there. Controlled traffic farming is ensuring that we're not overdoing it in one particular style or another. In essence, you are monitoring the impacts of each type of farming involved, and you're adjusting the others accordingly. Now, the preventative measure here, if we want to prevent it, we have to use soil and crop management. By separating those, conservation, tillage, mulch farming, and contour farming are all designed to help manage the soil. Whereby for crop management, cover the crops in planted fallows, vegetative hedges and barriers, strip cropping, multiple cropping, improved crop management practices. Now, if we're trying to undo some damage that's already been done, we separate into runoff and slope management. We know that soil will not move unless it has a reason to. So, slope management might be trying to ensure that it doesn't have the opportunity to start going on its own. So we start having diversion channels, graded channel terraces, and engineering structures to serve as impediments. If we're on a hill and it's starting heavily rain, then that rain is going to wash off some of that topsoil. By using these sort of barriers, we can prevent that soil from going off property and we can reclaim it. Runoff management, such as vegetative barriers, water reservoirs, and check dams, do the same thing, but they're focusing more on stopping it from being lost in the waterways as opposed to just being lost on the earth. Soil contamination. Now, this table here, or this flow diagram here, shows different types of soil contamination we can have. We often separate into inorganic, so it's either metal or non-metal based, and organic, so derived from any sort of organism. Soil contamination is a global issue caused by pesticides, heavy metals, and plastic due to human activities. A very common one is lead. Short-term effects for lead exposure include nausea, vomiting, muscle pain, fatigues, and seizures. It's believed that the Roman Empire used large amounts of lead piping. Now, over time, people who lived in that area and drank extensively through the lead pipes began to suffer lead poisoning as a result. Long-term side effects include lower IQ, nerve damage, kidney disease, bone disorders, and cancer. Now, luckily, we don't use a lot of lead in pipes anymore. Instead, we use PVC piping, we use copper piping, we use other insulative materials that don't wear off as easily as water flows through them. Arsenic is used in fertilizers and wood preservatives. Now, naturally, it can build up in water and rice paddies, and arsenic is incredibly toxic to the human body. You'd want to avoid it at all costs if you can. Cadmium is a heavy metal that's released by smelting iron, lead, and copper ores. It's most common as a heavy metal in Chinese soils. Now, in China, some government policies have been trying to destroy various heavy metals in very unsafe ways. For instance, burning car batteries. Now, as a result, this creates huge amounts of air pollution as well as leaching heavy metal into the soils and killing off lots of plant life that could be advantageous for them. But seeing as it's easier, that's what they do. Introduced species. Now, in Australia, every kid has heard of introduced species from primary school onwards. The idea that when the European settlers came here, they brought plants and animals with them, and once they got loose in the native ecosystem, they started causing problems. An ecosystem, by definition, is an environment plus all the living organisms that are in it. Terrestrial refers to anything that's based on land. So, for instance, here we might have rabbits, deer, feral cats, pigs, camels, horses. Now, by horses, I don't mean domesticated horses that live on a farm. I mean wild brumbies that were brought over and have started trampling tons of alpine areas, particularly in the Blue Mountains. As such, they've been often seen as a pest. Now, introduced plants can affect soil and water chemistry. For instance, if we to willow trees. Once they were introduced into our waterways, they took off like wildfire, and as such, they're often found based around the sides of many rivers. Now, in doing so, their extensive root system has choked out other native plants and made it possible for other introduced species such as carp to thrive. Introduced animals can affect soil compaction, crusting, siltation, and erosion. Again, wild brumbies in the Blue Mountains. Soil compaction is due to their hooves crushing various native grasses that weren't designed to have that sort of impact put on them. So the amount of ground cover that's happening up there is decreasing, and as such, they're more likely to suffer from erosion. Now, both of these are what we call abiotic factors that are affected. So they're things that are not living that have been impacted by introduced species. biotic factors might be forms of competition. So introduced plants affect outcompeting native plants for light, space, water, and nutrients. Again, our willow tree as an example. Introduced animals competing for space, water, and food, consuming and poisoning native species and introducing exotic diseases. Cane toads, perfect example. Cane toads naturally secrete a toxin from their skin. Now, if another native predator, for instance, let's say a dingo, tries to eat them, it'll kill them. So native species who try to eat the cane toads will die off, whereas the cane toads themselves will continue to breed and multiply constantly. Rabbits are another example. Rabbits are able to breed prolifically, and since they occupy the same sort of biome as bilbies, they offer the same area on the food web, bilbies couldn't reproduce as fast as rabbits. So the rabbits outbred them, and bilbies are now considered an endangered species, or soon to be extinct, provided we can get a hold on them in terms of rehabilitating their numbers. Rabbits, as such, along with pigs, cane toads, camels, horses, feral cats. In the old days, they used to have people who went out and professionally shot them. And over time, they would collect a number of tails from them, go in, and get paid for it. If you've ever seen the horror movie Wolf Creek or Wolf Creek 2, the lead villain of it is actually claiming to be a pig shooter, which was a legitimate profession back in the day. Of course, they didn't hunt people. Now, if we're looking at something aside from terrestrial, we can often look at aquatic and marine ecosystems. Aquatic being anything that's freshwater based. So here on this map, we have the density of European carp, low being blue, high being red. Now, by the introduction of carp, when they reproduce, they dig up the riverbed in order to lay their eggs. But in doing so, they're decreasing the amount of soil that's being retained and increasing soil loss and soil erosion. And again, we've separated them into non-living factors and living factors. Marine are saltwater based. Now, introduce fish in marine ecosystem by outcompeting native species for food. Because the marine ecosystem is so massive, affecting factors such as abiotic is not as much a concern. I mean, it still is a concern, but it's not a higher priority as it would be in an aquatic ecosystem because of the sheer amount of space they have to work with. The biggest concern would be how they affect the food web by competing with native species. All right. Now, for point 4.4.2, conduct an investigation into a local introduced species, including a reason for introducing it, biotic and abiotic factors of the species, areas affected, human impacts, control and mitigation methods, economic impacts, different views of the value and or harm caused by the introduced species, including views of Aboriginal and Torres Strait Islander peoples. So here we have the estimated cost required to rehabilitate from an introduced species. Number one here is cats, which is approximately $18.75 billion. Then we have rabbits, fire ants, annual ryegrass, pigs, Parentium, foxes, ragwort, cucumis melons, and heliotrope. And this is annually. I don't think that's annually, but now the one we focus on here is rabbits because they're the longest one. Please ensure you do your own research on this. Obviously, don't take anything that I say for granted. Make sure you talk to your EES teacher about this stuff. And already we have here some reasons why rabbits are a massive problem. Sorry about the yawn. Okay, so as humans use native ecosystems for a variety of purposes, introducing non-native species can throw out the natural balance of native flora and fauna. To become invasive, a species must meet the stated criteria. 1. It needs to have a very high productive success. So rabbits are able to reproduce like mad. We're going to use rabbits for an example here. 2. Successful dispersal over a large range. Because of Australia's varied climate, many of the areas where rabbits were introduced by settlers is in fact temperate, which suited them quite fine. So they're able to disperse over those areas and slowly migrate into more extreme environmental conditions over time. They weren't always successful, like if you go out towards the desert, there might not be rabbits there, but if you go further east or south, there's more likely to be found rabbits. Few to no natural predators and or disease. Because Australia was isolated from the other continents for so long, we didn't actually get as many of the same pathogens as they did. So while the Europeans were suffering through the Black Plague, down here in Australia, we were happy as Larry. Now, when it came to natural predators, Australia doesn't have many large predators like Asia or Africa or Europe or the various Americas do. Instead, we've only got one or two, which might be the dingo or snakes. They're probably the biggest ones. We don't have major big predators that would consume an entire rabbit. Generalists, able to use a variety of food types and habitats. Rabbits are great at this. They're very general, so they can eat a lot of variety of grasses or native vegetation. And 5, a very high cost to remove. Because rabbits are quite quick, they're able to adapt to many of the ecosystems here in Australia, and they breed prolifically. They're very hard to keep the numbers down. So people who go out rabbit shooting out here, it's pretty common, and in fact encouraged, because it can stop them from destroying native plant life. Human behavior often favors introduced species over native species due to various processes throughout various ecosystems. Now, the reason why we brought rabbits over here is because European settlers missed hunting them. They missed hunting them. Now, an individual rabbit is probably ignorant of its circumstances and is trying to survive. But the hundreds of thousands of rabbits, probably even millions of rabbits that we have in Australia now, are causing major concerns and problems. And it all started because some bloke from Europe said, wow, I really miss hunting. I'm going to bring some rabbits with me. Great work, mate. Fantastic. Same kind of thought process what went into trying keeping the cane beetle process down by introducing cane toads. Became more of a problem. This imaging on the right hand side would also be beneficial for you to get down. Introduced species can be negatively impacted by that's a typo there. You can damage the ecosystem, outcompeting them for food or water, preying upon native species. Okay, so native species can be negatively impacted by introduced species through damaging the ecosystem, outcompeting them for food or water, preying upon native species, spreading diseases, and poisoning native species. The many examples that we talked about in this video are perfect for that. Okay, whether it's destroying native grasses, being able to outbreed them, consuming native species, spreading diseases that were introduced, or just by their nature being so toxic they can't be eaten. This table is a very good show of how we go from being just introduced to becoming a major problem. Alright. Inquiry questions. Please ensure that once you have finished the topic in class, you can have a crack at these 3 questions comfortably. If for whatever reason you feel like you can't grasp something or you can't explain it properly, go back over it and make sure that you dot the I's and cross the T's. Alright. Now, for many of you who might be going into an end-of-year exam for Year 11, these are the various aspects that might be covered in said exam. And naturally, it's going to be very different to the one your teacher gives you, so ensure that any information that they give you, you get down. All right? The biggest thing I want to bring your attention to is the stuff down the bottom here for skills. You need to be able to read and draw graphs. Interpreting visual data is crucial when you're looking at any form of science, in particular, earth and environmental science. You need to be able to draw and label diagrams. You need to be able to design and conduct an investigation. Now, if you can do those 5 things and you can do them comfortably, then you've got many of the skill questions sorted. The content questions, you're going to have to go back over your notes. Okay? Alright, that's it for this video. This is the last one for the Year 11 segment. Please ensure that you have a crack at looking at any of our other resources or promote them to other people who are doing junior science. As always, I've been Furry. You guys have been amazing. Good luck with your end of your exam. I'll see you around.